We're looking at this integral, and at first we might want to draw this, so let's go ahead and do that. We'll notice that the dx's go from 0 to 24. It's going to be something like this. And then we even have this dz going from 0 to infinity, so we kind of know it's going up the page like this. And we have our dy. Well, we have this equation, y equals x over 8. That's going to make a line kind of like this. And if we plug 24 in for x, we're actually going to get 3 for our y over here. So that's kind of what's going on over there. And you'll notice that it goes from the line to the 3. So it's kind of more on the top side like this. Okay. So, and it's also going upwards in the z direction. Now, let's not be too intimidated by this middle integral here, because we do see that if we were to take the partial derivative of z in here, what's the partial derivative of this? It's actually minus 2z. So that's kind of cool, because we see a z on the outside, which is kind of what we need. So we don't need to really do anything for this integral. We can just solve it. We could just basically put e to the negative y squared minus z squared. Here's the z on the outside, and we'll just go ahead and integrate that by dividing it by minus 2z. And the z's will cancel, and we're going from 0 to infinity. So that's nice. If we put this in a little bit easier to read way, it'll be more like a minus 1 over 2e, and here's y squared plus z squared on the bottom. And then this is still going from 0 to infinity. So when we put infinity in for the z here, e to the infinity, this basically just becomes 0 minus, this thing is going to go in for the z, and then we'll have to basically add 1/2 e to the y squared in there, and 0 for the z. Okay, so this is the answer to the integral. It basically comes out to be 1 over 2 e to the negative y squared, something like that. And now we're looking at the next part. So we have double integral, and then there's going to be e to the negative y squared. You can put that over 2 or whatever. Okay, and here we're looking at this, and if we have the dy on the inside, and we try to integrate that, it'll be really, really hard because there's no y here. But if we were to be able to stick a y here by maybe flipping these, going dx dy, you could use that, and then you stuck a y here because now you can integrate this real easily. Well, now we could do the same trick that we did before. We just divided by the derivative of this. So we just stick the y there by switching the integral limits at this point. So let's go and do that. If we go dy on the outside, it means that we're basically going from here to there, and we're going to use a line like this. So we're basically going from 0 to whatever this thing is in terms of x, which x equals 8y. So that's the line that we're going to use there. So we go from 0 to 8y, and then now 0 to 3 for the y's. So now we could just integrate this by saying x e to the negative y squared over 2, and this is going 8y to 0. So it just goes 8y e to the negative y squared. This will be over 2, and then we plug 0 in there, you get nothing. So this is the next step. Now we could try to integrate that over the final integral, which is dx. Or no, sorry, we just integrated dx, and now we're on dy as the last step. So we got 0 to 3, and then this will be a 4y e to the negative y squared over dy. And here again, we'll just use the trick where we just basically 4y e to the negative y over 2 and divide this by negative 2y. These will go away, and you'll be left with a 2 on top. And you'll have a negative 2e to the negative y squared going from 0 to 3. So that means that you'll be able to say the final answer is like minus 2 e to the negative 9, and then plus 2. That would be cool. You could factor this out by saying 2 and then 1 minus e to the negative 9. Yeah. It's pretty crazy.